Welcome back again to the Mad Skills series on performance debugging. In this episode, we'll talk about stack sampling using Android Studio and how that fits into this performance debugging story. Stack sampling is super useful because it provides a ton of information about what's happening and why. You are looking at full stack traces after all. But collecting each stack trace does have a performance impact, so we can't rely on stack traces by themselves to understand how our app is doing. And there are a few other gotchas along those lines that you might run into as well. So let's jump in. So we're looking at a Systrace, like this one of our favorite Google I/O scheduling app from earlier. Let's say that we think this bind application is taking too long, that we think this app should be starting up a lot faster, and we want to make sure that everything that's going on is absolutely necessary. But there are no trace points in this section, so we don't have any more information about what's happening during that time. In order to dig more deeply into what's going on here, we basically have two options. We could either go into our app code and add additional trace points to try to narrow it down, or we can take some stack samples using the sampling profiler and look at those to understand what's going on. We've already talked about how to add trace points in a previous video, so today we'll focus on the stack sampling option. Now I really want to take a moment to emphasize that it can be really risky to look at stack samples by themselves. If you haven't contextualized your stack sample by collecting a systrace first, you can be led astray, and this is for two reasons. First, it takes time to actually collect the stack samples. So we cannot use timing information from a stack sampling profile to understand whether something is taking too long. It's usually best to start by looking at a systrace, see what's taking longer than you'd expect, and then look at a stack sample with that context in mind. The second reason is that on Android, work is sometimes distributed across threads and sometimes even across processes. You could be doing a binder transaction on your main thread, and the work is actually being done on another thread or even in another process. If most of the work is actually being done on a different thread during the time period you're concerned about, and then you stack sample the UI thread, you can end up with a lot of stacks that implicate the wrong thing. So it's super important to take a look at the trace first to figure out where your problem is, and then go from there to sample the stacks. Using these two tools together can be super powerful. So let's start by taking a look at the bind application I mentioned before. In this case, we can see this big chunk of time on your main thread where the CPU is running. Remember that this narrow row here at the top represents the CPU state. Green means running, light gray means sleeping, and yellow means waiting. Often that means blocking on I/O. So we can confirm here that the work that we're curious about is actually happening on this thread. Now let's take a look at the stacks. We can collect stack samples on boot the same way we collected systraces. Edit configurations, profiling tab, start this recording on startup, and CPU activity. For systrace, we selected trace system calls, and for stack sampling, we'll change it to sample C++ functions. Now this is actually a bit of a misleading name. This tool uses simple perf under the hood, and it will actually show you your Java method calls as well as native functions and syscalls. So this is the option I prefer. Note that trace Java methods will actually instrument and trace every method you enter and exit, which tends to have way too much overhead to be reasonable. Sampling can technically miss work that happens fully in between samples, but I find the trade-off in usability to be worth it. Then apply and OK and click the profile button to start. And we'll wait for the app to start and then go ahead and stop profiling. So over here on the left, we're looking at a graphical representation of stack samples for each thread in this process. So you can see there's a lot more CPU activity in this section where the app startup happened, so let's highlight that. Then let's click Flame Chart on the right side here to see a flame chart of that area we selected. Note that you can see the stack samples from multiple threads on the same flame chart if you click and drag to select. And don't forget that you can reorder the thread rows so that you can select only the threads that you want to see. So now we're looking at a flame chart of stack samples. Each of the levels here represents a function, and when that function is divided into multiple sections, we're seeing the proportion of stack samples that were taken that looked like this section versus like this section. So again, I want to emphasize this is not exact timing information. It's just the proportion. And if you'll remember, from the beginning we wanted to look at what was going on inside the bind application. So let's find that function in the stack samples here and zoom in on it. You can highlight certain text in a stack sample by using the search box here. When we type bind application, you'll see that the functions that include bind application are bolded, and functions that aren't in the call stack for anything bolded are faded out. You can use WASD just like in a systrace to move around and focus on the area that you're interested, but make sure you don't cut off anything that you want to see. Note the color scheme here. The dark orange represents Android platform code, the light yellow represents functions that are within your app, and this dark yellow represents Java functions. So all of a sudden, we have a ton more visibility into what was happening during this function, which was completely ambiguous when we were looking at the systrace. We can see that a lot of the CPU work in this section related to setting up Dagger, and another big chunk had to do with setting up content providers, both of which happened in your app code. And there's another smaller piece over here where the Android system preloaded the fonts your app will use. Now this was way easier than adding trace points, and now we have a pretty great understanding of exactly what was happening during the CPU time in that bind application trace section. I hope you can see how stack sampling can really come in handy, especially when you use it in conjunction with Systrace. And that's all for today. In the next episode of the series, we'll talk about the Perfetto Trace Viewer and when it might be useful for your performance debugging needs. See you there!